Dr. Knag,
Dr. Bilo,
the Timmer House.
Rotterdam.
It's in principle, is that the City Hall of Rotterdam? Sort of, no?
It's kind of a city hall of...
Part of.
Part of. There's another part there, there's another part there. And designed and nicely engineered, a lot of super nice glass structure. OMR were the architect.
Yeah, Helm Kohlhaas.
Kohlhaas. We're going to see Mauro Overend, Professor Dr. Mauro Overend.
Our colleague.
Our colleague. He's a glass freak, glass specialist, and the professor for structural design. And we're going to talk about, obviously, structural design of facades.
Ah, that's wonderful, because the building has so many different variations of it. But we start with the standards for today.
We start with the standards.
Perfect. Thanks. Let's have a look.
Let's go. Yes, get in, get in. What a shitty weather. Oh my God. Let's go. Come. Okay, so Mauro, structure design of facades, dead load, payload, impact load, building structure, facade structure. What do you need to know as a structural engineer by designing facades?
Right, so first of all...
You may take it, but I'm going to take... Yeah, yes, okay, but I get it back, huh?
Okay, yes, sure. So first of all, you need to know that the principal aim of structural design is to prevent the facade from failing in any way that will injure somebody or will prevent some loss of function in the space, for example. Okay. Now, to do that, you need to account for all the loads that are acting on the facade. Number one is a dead load. So what are the materials that are used in the facade, how much do they weigh, and how are those loads transferred from the panel to the frame system, to the load-bearing structure of the building in a safe way. You then need to check your horizontal loads, and with horizontal loads you have, number one, wind, because facades are exposed to wind, and this will depend on where you are, the wind velocity, the other buildings that are obstructing your building. So the wind load is calculated on that basis. Then apart from that, you also have horizontal loads from possible impact. Yeah. So someone, full height glazing, on the third or fourth floor, stumbles and hits the facade from the inside. You don't want that person to fall out, clearly, so the facade must resist that impact. And then you also have hard body impacts from outside, if perhaps through vandalism, maybe through maintenance, where if you put a ladder or you're using a cleaning cradle, you want your facade to resist that impact. Yeah. And then there's other extreme loads. Could be in some areas you might have a blast risk, maybe a risk of explosion.
True.
This is maybe quite specialist and quite extreme, but it is possible. Yeah.
And then these loads, as you said, they come from the panel, they get into the system, and then they get down to the building. How does that work?
Correct. So the best way to look at it is from where the load is acting. So if you have a wind load, the first thing the wind load acts on is on the glass panel, in this case, right? So the glass panel must transfer that load safely to the frame, to the facade frame system, whether horizontally or vertically, but in this case probably more horizontally because the span is shorter horizontal. So then this mullion in its own right must transfer the load to where it is connected to the structure. In this case here it's in the ground, but as you go further up it might be connected to a beam or edge of slab in your floor.
Yeah. Okay, so then the structure, then the loads from say the facade are transported down and brought into the main structure.
Yes.
But what happens if I have more than just one floor? What's with the second and the third floor?
Yeah.
You may take it again.
Thank you. Thank you. So, if you have more than one floor, typically you would try to take those loads at each floor.
Okay.
So each floor is each panel is supported, not always, but typically at the top part of the floor, and it hangs down one floor, and it's connected to the bottom floor.
So per floor, the loads are transported and then brought into the main structure of the building.
Correct, and right through the main structure of the building.
Okay.
Yeah.
So that's what we actually see here when we look at this system, which is an aluminium stick system.
Yeah.
We see the inner main structure,
yes,
which obviously somehow takes loads of
correct,
the system.
Correct.
Okay.
Yes.
I get it. I take it again. global design, facade structure, detail and connection to building. So we learned main structure stays and the outer facade is a separate structure which brings its loads to the main structure. How is this connection done and what do we have to take care of?
Yes, very good. So you have the main structure, which is made of steel, made of concrete, made of timber, the main load-bearing structure of your building. And your facade structure is sometimes, quite often, made of other materials. It might be made of aluminum, out of glass. Yeah. So these two already have different movements. So the facade and the main structure might expand and contract in different ways, so you have differential movement. So in order to do that, you need to make sure that you leave an expansion, a tolerance for movement between your facade and your main structure.
Okay, so we have the one which is somehow moving versus the next one which is somehow moving, so we have to make sure that they don't touch each other.
Correct. Correct.
And now?
Yes. So you connect one end, for example, the top is connected so it cannot move in 3 directions, whereas the bottom end will only be connected laterally.
Laterally.
So out of plane.
So there's, say, this is fixed here and it's kind of loosed here.
Correct. So it can expand and contract without stressing each other.
Okay.
Yeah.
Good.
Yeah.
How to decide the system, the material. You're the structural engineer, but you deal with all these different types of systems. We mainly talk about stick systems, unitized systems, this kind of things. That decision, how are you influencing that one? And if that is done, which material to take for the structure of the facade?
So very often the system is guided by, or the material is guided by the architectural intent. So perhaps it could be stone, it could be glass, it could be aluminum. So this already dictates to some extent what the structure or the material for the structure should be. If it is a curtain wall system, so it's glass and some metallic frame, typically steel or aluminum, or maybe even timber, but typically steel or aluminum, then the choice there on whether to use a unitized system or a stick system is mainly governed by the manufacturing process. So do you want to, and the assembly process. So do you want to assemble most of your facade in the factory and come along with a big panel and simply attach it on site? Or do you want to bring the system to the site as separate parts and assemble them on site?
This is a stick system.
Correct.
So this is assembled on site, so they have the posts and rails assembled at the site, then brought in position.
The glass is brought
separately. The glass is brought in and
Correct.
then it's connected. And unitized system, you said that's a unitized system.
Yes, correct.
So that comes as one block.
Comes as one block, the frame
is brought in position and then it's brought in.
And it's simply hung and attached with those connections that we mentioned earlier to the top and the bottom of the floor.
Influence, is there any difference between, say, this system from your structural point of view for the main structure from this system to this system, to the stick system?
Structurally, there's not a big difference, between the two, because the materials can be the same and the glass is also the same.
So say this decision about the system is not influenced by the structural design, but by a logistic, for example, if you want to. Okay. Then material, you said it could be timber, it could be aluminium, it could be steel. Well, they have different properties. As a structural designer, you should have an opinion about that.
Yes, of course, yes, they have different properties. So the ideal material from a structural point of view would probably be steel, because it's the stiffest and the strongest. But also, you have to consider whether you want something which is maybe more lightweight or you want something which is sustainable, and perhaps that's why you might use timber in that case. So you will end up with a cross-section. This member here, the one behind it, will be much bigger in timber than if we were using the same same structure, but for steel, for example.
So design-wise, I may have a say in the different types of material due to, say, the appearance of the building, but structurally speaking, the timber structure is going to be larger than an aluminium structure, than a steel structure.
So it goes steel, smallest, aluminium, a bit larger, timber is the largest.
And why do we see here an aluminium system and then a steel structure behind?
Very good question. This is a particular facade where we have 2 or nearly 3 stories high. So the aluminium structure itself, this aluminium mullion, is not sufficient to resist 3 stories worth of horizontal load. So it needs an additional, in this case, steel structure to support it. But if this was just 1 story, you would only see the aluminium. There would be no steel.
So Listening to you, I would take the alternative. Instead of aluminium, a steel frame system may work.
Yes.
Okay, and then I'm getting rid of the steel I-beam at the back
Correct.
as a setup.
Correct.
Okay, I think we are done. Thanks.
Thank you.
Let's go.
The thing that you could see here is that the lower part is a different system than the upper part. If you, from the outside, you have the unitized at the top, and then there's more bespoke.
That's a good one. That's what we do outside.
Yeah.
I must say, we do it in that way that
Not so much about structure, but it's the two different systems on the same building.
that you may videotape us while we're discussing it with two umbrellas at the outside. Umbrellas.
that's very good. So
Yeah?
we can
Good.
stay in the
Yes. As we discussed it, and then there's a unitized system at the top, and they come as units which are hung in position.
Yeah, correct. Yes. So the bottom is built on site. All the elements, the glass, the mullions, the frame is brought separately on site and built on site. And the top unitized system that you can see there, this comes as panels which are prefabricated in the factory with the frame and the glazing units all installed in the factory and brought as a panel and installed on the building.
When we look at this place, we see it's a rather small street. So logistically, this makes sense. To have this prefabricated and then installed rapidly.
This is a city center, so you don't want to close all these roads for several weeks or months, so you can install the unitized system very quickly.
This is what they actually do there.
Yeah.
They close it for several months for the different constructions at the other side.
Of course, for something else.
Let's get inside, it's too rainy.
Yes.